a water tube type low mass boiler, you have the pressure drop of going through that heat exchanger plus through an indirect water heater is substantial pressure drop. And in this case, we're lowering all of that with this type of device, the parasitic losses. We also are not flow sensitive. Low standby heat loss, we have 0.5 degree per hour, very low standby loss on these devices. And we have the thermal mass. All the advantages that we've had in the past with thermal mass can now be taken advantage of with this kind of device. And then we have a minimum 20-year design life, and I'll go into that a little more in a moment. Let me just switch over to any questions here. When will solar version be available? Well, the solar version, we will have our inventory in a decent shape by the middle of January. We have inventory in bits and pieces coming in, but that's our projection. So that's coming out concurrently with the standard version. There's really no separation in terms of release date on these. We've already had a number come in, but of course they were gobbled right up, and we're just trying to keep up with demand. But it's, again, probably going to be mid-January before we can catch up and actually have enough inventory to meet all the demand that we're seeing right now. Okay, can we get a copy of the slideshow after the presentation? You betcha. Just give a call, ask for Zach, and get you a copy, and no problem. What you will be seeing is segments of these kind of PowerPoints going up on our website regularly here on different subjects, not as long as this, but certainly any time you want any of this from us, let us know. Does Phoenix come in electric in lieu of gas? No, it does not. This is a gas-fired device. We are releasing a air-to-water heat pump, which you will be hearing about soon, which is an electric version of doing combined hydronics, space heating, water heating, and cooling, and you'll see notice of that starting the first week of June. So will evolution sense solar hot water production and stop the burner from firing? Yes, because what it's looking at is just what is the conditions in the tank. So in part, that's why that logic is there, to make sure that if the tank is sufficiently warm, it will not fire the unit. And that would apply to solar as well. Okay, include the solar version throughout the presentation. Okay, well, that's a good thought. In fact, what I've done is put more of it towards the end. And that's a good suggestion for the future. So, what, in fact, the evolution turned out to be is a virtual perfect match for what John Siegenthaler considers to be the ideal hydronic device. And why? What's some of the background here? Well, in boilers, there are really two different types. There's a water tube type of unit, and then there's a fire tube. A fire tube, and these can be in huge boilers, small boilers, or in this case, condensing water heater. This is a cross-section of an Evolution or Phoenix, where we have a combustion chamber, which is a cupronickel and stainless combustion chamber here, that is surrounded by water. So what you're doing is taking the energy to put this air, hot air, and progressively cooling air through this chamber, but the exposure to the water is very good, and it turns into a situation where you have whatever's coming out of that tank is not flow dependent at all in terms of the design of the unit. It's basically hydraulic separator, and it's indifferent to what the flow characteristics. Now, a water tube heater, which could be an RBI, a Raypak, a Teledyne, a Giannoni type design, any of these, the cast aluminums are there, where you have a burner that's burning in the middle here, and you have water going through the tubes. Now, and then the air is going through these, whatever the design is, relatively small passages to heat the water inside those tubes. the byproduct, and it's a very nice design, but the byproduct of that is you have pressure drop conditions for your water going through, and associated pumping going with it, and the require to keep full flow through a water tube heater so that it will not short cycle. You also have to restrict the airflow going through any of these devices in order to get the coverage over the heat exchanger type, which leads to, if you have air quality problems in your combustion air, it can pose a greater problem with a water tube heater than in the case of this fire tube device. It's very hard to get a incoming air problem that will create a fouling of any heat exchanger here, as well as it's virtually impossible to have a condensate backup of these kind of units and create any problems for the units. Very hard to overcome, impossible virtually to overcome the head of the backing up in this system. So there's simplicity to these and greater overall efficiency to the design. So Phoenix Evolution design versus a low mass boiler or a tankless water heater. And you have to keep in mind that Heat Transfer Products manufactures 5 different lines of boilers. We love our boilers. They've progressively improved to a point where very, very reliable devices. However, from a design perspective, there are differences and limitations to the different designs. So in the Evolution design, we have a hydraulic separation. The low mass is flow sensitive, low pressure drop, relatively high pressure drop for a water tube, reduced cycling, definitely cycling prone in a water tube, low mass type of system, variable speed friendly, full flow is required, on-off flow through the low mass units, and there's greater simplicity in this type of design. Now, they have basically delayed putting out these products in order to make sure that they're very comfortable with the durability and reliability of these products, because originally they came out in '94 as a Voyager. I'm talking about the tank design. Since then, they've had over 200,000 tanks out there. Very, very few leakers of tanks, because it's this 316 stainless steel construction, which is far superior to a glass line unit, which will fail if the anode fails on those units. And it's a very hostile environment for a condensing unit as well. They changed the design at the top of the combustion chamber, because that was their one Achilles heel, to an 800H very high grade stainless, and that then is woven back into the cupronickel used in the construction of this combustion chamber and the secondary coils. Since then, they have not had one leak, period, across the nation, all of the units that have been put out. And those numbers, I'm just going to guess, certainly over 75, 80,000 units. They're very well convinced that this is a extremely rigorous design, and that's why they put a 12-year warranty on it, even within a potable water heating condition. So the warranty is comparable to a boiler. The reliability of this whole system in terms of the blower, the control, the gas valves, fundamentally when you're doing modulation and when you're doing high mass, you have less cycling. Less cycling is longer life. You have less strain on the boiler. We also have fewer parts on this. We don't have water pressure switches and a number of other parts in this. So these the component parts in here are very widely used throughout, multiple millions of applications. Now very comfortable with settling into them. The blowers have improved tremendously in the last